Hi everyone, and welcome to this video on quadratic equations for the Year 11 Mathematical Methods course. My name is Darren from Maths Guru. Yep, my little corner of the interweb where you can pretty much watch this whole course recorded, and if I do say myself, in a rather excellent way. So if you want to smash methods, hopefully I'll help you do exactly that. Right, what's his lesson about today? Well, as you see behind me, understand how we can solve quadratic equations using simple factorization and solve application problems relating to quadratic equations. Now, that's a bit of a lie. If I was going to show you every single application problem there ever was for quadratic equations, this video would stretch forever and a day. Strange expression, really. But anyway, so I've got one example, and that seems to shortchange you a little bit, but as the videos progress, and there are lots of videos on mathsguru.com, then there will be more examples thrown in there as well. And there's a lot of sort of common examples we use in exams and SACs and what have you to try and sort of test your understanding. And the thing about methods, as I say over and over again, is it's basically not about regurgitation. Methods requires you to understand the content. Now, when I get to recap past learning, which I've got here, what I'm trying to say now is if you are just starting this course and you do not have any understanding whatsoever from year 10 where you did quadratics, where you did factorization, where you did all of that simultaneous equation stuff, stop now. Don't go any further with this course. Now that sounds a little bit melodramatic, but I'm not trying to be melodramatic. What I'm saying to you is the quadratic stuff is massively important. In fact, most of the rest of this course is going to build on the same foundations as the quadratics are going to give you. Now, this is only sort of 3C if, the textbook hasn't changed around, and thank you very much, Cambridge, for allowing me to use your books. But the point of it is that the skills you are going to learn for this chapter is going to be used for every type of graph you're ever going to see in your entire life. Now, we're not going to deal with quadratics for too long. There's going to be all sorts of things like hyperbolas and truncus and R square root graphs. It goes on to infinity and beyond. But the key skills are important. All right. So if you are struggling with any of this work, I generally would stop. A lot of people say to me, oh, I should get a tutor to teach me year 11 methods. No, don't. Get a tutor to teach you the year 10 algebra. Once that's under your belt, and I mean firmly under your belt, year 11 will be so much easier. So what is a quadratic? Well, basically in its most fundamental form, it is a graph, what looks like a U, or if we turn it upside down, it'll look like an N. All right, so fair point. That's what a quadratic is. The thing about quadratics is there are a number of important points that you need to know. I mean, most importantly, I suppose, is the idea that this has an axis of symmetry. So everything on the left of that line and everything on the right of that line is exactly the same. So there's a line of symmetry. That makes life really important because somewhere on that line of symmetry, there is going to be the minimum point of our graph, or if it's an N shape, there's going to be the maximum of my graph. That's a minimum and a maximum is really important. There are going to be various points we can find and plot and help us to sketch. And most of the work you're going to end up doing is about sketching this stuff. Ooh, yeah. Now, here's another example of a quadratic. And again, this is really lifted from the year 10 type of work where we've basically translated it down. We've taken it. It looks a lot wider. Yes, that could be my scale, or it could be the fact that I've dilated it that way. But the point of it is, what do we have now? Well, we still have our minimum point. That's critically important to help us sketch. And there's lots of ways of helping us find that minimum point. But more importantly are the points here where it is on my x-axis intercept. Now, one other point I haven't labeled, but probably should have done, is that point there, which is my y-axis intercept. Now, for the whole work through Mathematical Methods, Units 1, 2, 3, and 4, you are going to be asked to sketch functions, sketch graphs. Now, that's not just sort of randomly putting a sort of a U shape on the graph and going, yay, I've done it. What it's asking you to do is specifically use the algebra to find these crossing points, this minimum, that crossing point, and anything else for later polynomials when you do cubics and quartics and what have you. So the maths behind finding these crossing points, this minimum and that point there is really important. All right, now, as a recap, there are 3 types of quadratics, and I call them types 1, 2, and 3. Now, if you put this in your summary book and then you look at a question in the exam and go, oh, I don't know, what type is this? Well, it should be hopefully obvious once you know the type to be able to find the way to actually solve it. And solving it is basically finding my x-axis intercepts. Now, this is what I call type 1. Basically, it's just got a square term and it's got a constant. That's it. Notice that there is no x term. Now, you're going to try and say, but there is an x term. No, that's an x squared term. There is nothing in the middle of this. So when we have an x squared minus 4, there is one way of solving those equations. Now, again, we can try and trick you by writing it in all sorts of different ways, but that is what I call a type 1. Type 2 in this situation is it has an x squared term and an x term, but no constant. Now, in that situation, life becomes much, much easier because it's a basic factorization question, believe it or not. So if I was going to take this question here and say, well, there's x squared minus, he says not reading it, 4x equals 0. I now know, because it's a type 2, that I'm just going to take x out of my brackets, gives me x minus 4 equals 0. And those of you who understood the algebra for all of year 10 go, oh, that's a null factor law question. Absolutely. So now simply x equals 0 and x equals 4. Now, finding that, yay! All right, using the algebra to find it is one thing. That's regurgitation. Understanding what those two values are looking at or mean, that's the understanding. And that's there realistically what we found is our x-axis intercepts. Ooh, now type 3, which is the ones probably I'm going to focus on a little bit more this lesson, is that one there, which is the x squared minus 3x plus 2. Now notice here, we have a squared term, we have an x term, and we have a constant. Now in that situation here, those are the more tricky ones, and there are a range of ways of solving this, but let's have a look now. Now, when I was at school, I was taught something called the T method, and it has lived with me from this day forward. Why? Well, basically, it works for every single quadratic. Well, actually, it doesn't. But I know for a fact the ones it doesn't work for, I can actually use the quadratic formula to help me solve those type of questions, or my CAS. But at the moment, we're going to sort of ignore the fact that the CAS can do this for me. Right, so the T method works on a huge number. And basically the idea is, if you've got something of the form of ax squared plus bx plus c equals 0, for example. In fact, it doesn't need to be equal to 0, because equal to 0 means we're just solving it. We're actually finding the specific locations of the x-axis intercepts. What I was taught at school was this. You draw a t, and you simply take the a value and multiply it by the c value. Now, again, we have to be very, very careful here, because that can be a negative, all right? So remember, that can be a positive, or it can be a negative, and we have to take account of that on my value of c here. And then once we've got this value here of a times c, we just have to find all of the factors of that number and list them. All right, now again, this might sound confusing. Some people teach the cross method. I'll be honest with you, never made any sense of the cross method whatsoever, but hold on, that's down to you if you understand it. So here we go, here's an example 1. So the first thing I always do is say, right, okay, what type is it? Well, it's a type 3 quadratic. It's got an x squared term, it's got an x, and it's got a constant. Now, the fact it's equal to 0 is the reason where they've given me solve. So I've got to find the specific values of x. If it didn't have this equal to 0, then I'd be just factorizing. And again, the T method will do that for you. Right, so again, let's rub out all of that for the moment. If I remember rightly from my theory from school, I now draw a t, and I take my a value and I multiply it by my c value. Now, my a value is the coefficient in front of the x squared term. Well, that's 1. And then my c value is 24 plus 24. And 1 times positive 24 gives me positive 24. Now, you may turn around and say, why on earth have you written the positive? And I don't know if I've got lots of examples of this, but it becomes really, really important. Right, 24. Now again, my teacher taught me, once you've written the plus 24 on there, the next thing you do is you find all of the factors of 24. So I've got 1, I've got a highlighter there, don't know what happened there. So let's try that one again. I've got 1 and 24, 2 and 12, 3 and 8, 4 and 6, 5, nope, 6 and 4, 8 and 3, 12 and 2, and 24 and 1. Now, when you do more of these, you will probably notice that actually my factors are repeated. They're just in a different order. Now, actually, in that situation, once I realize I'm going to reverse my factors, you get to a point where you go, well, actually, I don't need those for this moment in time. Because having found the factors, the third step of this is to try and find a pair of numbers which, when added together, gives me the value of b. Right, so you've taken your A, you've taken your C, and you've multiplied them together. Once you've done that, it's almost like you've forgotten the question. And then you look down here and you go, well, okay, what am I going to do now? Well, I'm now going to follow stage 2 of this, which is find all of the factors of positive 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Now, stage 3 is find two numbers which, when added together, will give me plus 11. And again, that's really, really important, positive 11. 1 plus 24, no. So that's no good. So again, normally I would, when I was at school, cross that through. It's no good to me. 2 and 12, 14. 3 and 8 gives me 11. There are my two factors. Now, again, there are a range of shortcuts because actually the more you do of this, when you realize this is a monic, you can actually go straight to your answer. But I'm not going to do that at the moment. I'm going to show you the long method because it works every single time. And once you understand what you're doing, you can replicate it. Now, the reason we do this is we actually have, at this moment in time, 3 terms. I cannot factorize 3 terms because if you go back to all of your year 10 stuff, we can factorize pairs, we can factorize 4 terms, 6 terms, 8 terms. I can't factorize 3. So the reason we do this is we're trying to find a way of splitting up this plus 11x into 2 terms. Oh, hold on a moment. We know that 11 is created by doing 3 plus 8. Right. So what I'm now going to do is change my pen color because I can. The first term stays the same. So x squared stays as it is. But I've now realized I can split 11x into 3x plus 8x. That's what I'm going to do now. So I'm going to say plus 3x plus 8x plus 24 equals 0. How many terms have I got now? 4. Brilliant. So through the work we did in year 10, I now know that I can factorize pairs. So doing that first, what is the biggest factor I can take out of x squared and 3x? It's just going to be x. So there we go, x plus 3. I repeat the process and I say, well, okay, what is the biggest factor I can take out of 8x and 24, or plus 8x and plus 24? Well, in that situation, it's going to be 8, 16, 24, 8. So I'm going to take out plus 8. Now, again, the signs are really, really important. You can't just write 8. It's got to be positive 8, leaving me with x plus 3. Ha, 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 ha. Now, the reason I do that sort of maniacal giggle is because, well, I now know I'm actually on the right track. And the reason I know I'm on the right track is our teacher told us that as soon as the terms inside the brackets are the same, you're done. You're actually right. You can move on, finish it off. Congratulations. If they aren't the same, you're in a bit of a problem. Now, again, a lot of people try to say, well, where do I go from here? How many terms have you got? Now, if you turn around and say, I don't know, 6, it's not right. You've actually now got 2 terms because that multiplication sign between the x and the x plus 3 sticks all that together. That's actually 1 term. And that's a second term. And when you've got 2 terms, you can factorize again. So what's common to both of those terms? Well, it's the brackets x plus 3. So I'm going to move those brackets outside. That becomes x plus 3. Here's my set of brackets to write in what's left. Well, if I divide this by x plus 3, I get just x. And if I divide by x plus 3, I get plus 8 equals 0. Ka-ching! Now, having got that, it's the null factor law. So using my null factor law, I now know that x plus 3 equals 0 or x plus 8 equals 0. So x is equal to -3 or x is equal to -8. Now, again, that's regurgitation. All right. It's really now saying, well, do you understand what that actually means? And it means I have x-axis intercepts at -3 and -8, which is great because I've got so much information now that I can use to help me plot this thing. All right. Believe it or not, I now know that my y-axis intercept is plus 24. I know this is going to have a shape of a U, not an N. Why? Because that's a positive x squared term. I now have x-axis intercepts. And believe it or not, outside of finding the bottom point, which we'll come to a little bit later on, or the minimum, you've done the algebra behind it. Now, a lot of people look at this and go, wow, that seems complicated. Yes, maybe. For this example, possibly. But when you start getting coefficients in front of there, the T method works beautifully every single time. No guess and check, just beautiful maths. All right, and here we go. Here's an example now. Right, so again, this is a type 3 quadratic. Let's see what I've got to do. So I take my t and I take my a term and I multiply it by my c term. Now notice here I've got an a of 2 and a c of -12. So when I multiply those two together, I get minus 24. All right. Now, having written that on there, what do I do now? Well, I really disengage brain and I just try and find the factors of -24. Now, I'm going to leave the negative to one side for a moment because my factors of 24 are 1 and 24, 2 and 12, 3 and 8. What have I got? 4 and 6. And I said that they are going to repeat. Yes, they're going to repeat because I can just swap them around. Now, I'm going to ignore the repeats for the second. Now, that's through practice. If you need to do them, do them. Now, at this moment in time, I've got a bit of a problem because if I multiply 1 and 24 together, I get positive 24. I don't get negative 24. If I multiply 2 and 12 together, I get 24, not negative 24. How am I going to make them negative? Well, I can either make all the left-hand side negative, because that's going to work, or I can make all of the right-hand side negative. But which do I choose? Well, this is where a little bit of sensible stuff comes in, because what we know is we've got to try and find an answer. We've got to try and find a pair of these that when they add together, give me positive 5. Now, there is no way that I'm going to be able to do anything with 1 and 24 to make it add to positive 5. 2 and 12, nothing I can do there to make it add to positive 12. All right, even if I make it -1 and 24, -2 and 12, nothing I can do with those numbers to help me get to 5. 3 and 8, on the other hand, Now, if I was to do a negative sign in front of the 3, I would end up with -3 plus 8 gives me 5. Obviously, if I put the negative sign on the other side, 3 minus 8 would give me -5. That's not what I need. I need positive 5. So in which case, I am going to use -3 and 8. And once I've done that, I now follow the process through in exactly the same way as I did before. So I've got 2x squared. The first one stays the same. I now write -3x plus 8x. Again, remember the reason we're doing this is we're trying to split that one term into 2 and keep the equation exactly the same as it was. What have we got? -12 equals 0. Right. Awesome. We can now factorize our pairs and see what we come up with. Well, the highest I can take out of there is x. So that's going to give me 2x minus 3. The highest I can take out of plus 8x minus 12 is going to give me 4. So positive 4. It gives me x. Oh, no, it doesn't. It gives me 2x minus 3 equals 0. And again, if you've been watching the previous part of this video, I now know categorically this has to be correct because those two brackets there are exactly the same. So I factorize again. I take outside the 2x minus 3 and I write inside what is left, which just so happens to be the x plus 4 equals 0. So now using my null factor law, I get 2x minus 3 equals 0. X plus 4 equals 0. X is equal to -4. 2x is equal to 3. X is equal to 3 on 2. And again, it's no good just going, yay, I've done the algebra. You've just got to realize then that what does this now tell me? What type of information can I get from the equation and that? Well, I know it's going to have a y-axis intercept of -12. I know it's going to have x-axis intercepts at -4 and 3 on 2. And all I would then have to do is find my minimum point. Now, as I say, applications of quadratics are massive. There are so many different ways of asking quadratics, and hopefully as I move through videos in this part of the course, I'll show you more and more ways of using them, okay? But you really do want to concentrate on the applications. Right, here is one example that lots and lots and lots and lots and lots and lots of exams I've seen use in one form or another. The perimeter of a rectangle is 20 centimeters and its area is 24. Calculate the length and width of the rectangle. Now, when I was at school, my teacher said to me, hey, he didn't sound like that at all. He went, a diagram saves 1,000 words. And I was like, cool. Can I just draw pictures in my essays then for English? He wasn't impressed. Moving on. So here we go. I'm now going to draw a rectangle. Yeah, brilliant rectangle. Not its perimeter. Hold on a moment. I don't know the side lengths. Exactly. And the thing about methods is you've got to start putting in pronumerals where you can. Now, the best thing to do here is choose the values of x and y. Why have I chosen x and y? Because we know it's a, a rectangle. And so in which case we know that that is going to be bigger than that. So it would make absolutely no sense to choose the same pronumeral. We can't use x and x unless it was a square. And I've seen examples like that as well. So there's my x and y. I know nothing else, but let's have a look now. So we've got my perimeter is equal to. Now, if I was to work out the perimeter of this shape, what would I do? I would add all my side lengths together. So x plus y plus x plus y. Or two x's and two y's. Cool. But I know what the perimeter is. They've told me the perimeter is 20. Right, well, in which case I now know that 20 is 2x plus 2y. Oh, I've got even pronumerals all the way through, so I can divide all of that by 2, which is going to give me 10 is equal to x plus y. Can't go any further at the moment. Why? Well, because I have two unknowns. Two unknowns, two equations. All right, what other information have they given me? They give me the area is 24. How do I find the area? Multiply. So we now know that xy must equal 24. Hurrah! What do I do? Well, there are lots and lots of ways of going forward from here, but this is what I tend to do now. Because we've got two equations with two unknowns, I can now substitute one way or the other. I can either substitute that into there by saying, for example, x is equal to 24 on y. So where I see that x, I can replace it with 24 on y. That's certainly one way of doing it. I'm not going to do it that way. This is the way I'm going to do it because it makes a little bit more sense. I now know that x is equal to 10 minus y. Ooh, x equals 10 minus y. How is that going to help me? Because I'm now going to substitute that into here. So I've now got 10 minus y times by y equals 24. Multiply that out, it gives me 10y minus y squared equals 24. Maybe change the color back to black for a moment. And, it's so confused. No, you've got a quadratic. Now, the way I know it's a quadratic is because I've got a square term, I've got an ordinary term, and I've got a constant. Yes, they're all on the wrong sides from each other, but again, that is a standard trick we use in methods. It's just one of the easiest ways to throw you guys. So I'm now going to move everything over. Now, why am I going to move it over? Because I've got a negative y squared term. So I'm going to move that over to the other side, or add y squared to both sides. And that's going to give me that y squared minus 10y plus 24 is equal to 0. Oh, cool. What do I do now? Well, if it were me, I was going to draw my t. And I take my 1 and my 24 and multiply it. God, why do I keep getting 24s all the time? So 1 and 24, 2 and 12, 3 and 8 and 4 and 6. Right, so that was positive 24, and I'm looking for minus 10. Huh? How am I going to get minus 10? Well, 1 plus 24 is 25. That's going to give me 14. That gives me 11. That gives me 10. Oh, hold on a moment. That gives me 10. I don't want 10. I want minus 10. But I've got to find two numbers that when they multiply each other give me 24. And this really is the last trick that we try and employ in methods, to be honest with you. Because if we make each of these numbers negative, when I multiply negative 4 by negative 6, I get positive 24. But when I add negative 4 and negative 6, I do in fact get negative 10. So we now get, am I going to run out of space here? Y squared, what is it? Minus 4y minus 6y plus 24 equals 0. Take a y out, we get y minus 4. Take out minus 6, we get y minus 4. And again, multiplication becomes important. Y minus 4 times y minus 6 equals 0. Is that y minus 4? So therefore we get y is equal to 4 or y is equal to 6. Now, in this situation, it says calculate the length and width of the rectangle. Now, the great thing is here we have a bit of a dilemma, or do we? Because we got y equals 4. Now, if I put y equals 4 into here, so when I get y is equal to 4, I get x is equal to 6. But if I get y is equal to 6, x is equal to 4. And again, while we can regurgitate the maths, what does that actually mean? Well, as I try and point out over and over again, if I use this bit of paper here, which one is the length and which one is the width? Really? Because if I swap it this way here, which one is the length and which one is the width? Now, really, the orientation there just defines on what's going on in terms of what x and y is, but basically both of those would therefore be true. The length could be 4 and the width would be 6, or vice versa, depending on orientation. Now, if you look at this question, we started off with just the basics of year 7. Can you find out the perimeter of a rectangle? In fact, before we even went there, can you draw a diagram and write down just 2 pronumerals to use for the length and the width? Once you've done that, can you find the perimeter in terms of an equation? Cancel it down. Can you find the area in terms of an equation? Do you then realize that you've got 2 equations with 2 unknowns and you've got to basically do some substitution? Once you've done that, can you multiply it out? And then, having done that, can you identify that that's a quadratic and write it in the correct form before going ahead and solving it and then stating the answer? The number of students I see who basically give the answers or that line there and then never finish the question off, because the question clearly says write the length and the width of the rectangle. Now, obviously, probably here I should have written length equals 4, width equals 6, or length equals 6, width equals 4. Is that the same thing? I don't know. But how many marks do you think this is going to be worth in an exam? Yes, I would say 4, maybe more. 4 marks for basically all of this working out. Now, it's a great question to put in your summary book because, again, we use it so often in so many different forms. It's really quite a clever one. But for that, let's just call it a day. How long was that lesson? 27 minutes. But it's important. This is foundational, fundamentally important stuff, though. Did we understand how we can solve quadratic expressions using simple factorization? Well, we looked at the 3 different types, and then I showed you the T method. Hopefully that was useful. Solve application problems. Again, there was one application problem. Hopefully it's been helpful. Right, I'm done for this video. Thank you very much for watching. If you can subscribe to my YouTube channel, that would be massively, massively important and greatly appreciated. Obviously, there is mathsguru.com down here for you to go and have a look at as well. And hopefully I'll see you in later videos. All right, take care. I'll see you again. Bye-bye.